Okay, I want to get this video out to you here for number 36 to kind of explain. There was a picture next to this Ferris wheel problem. It feels maybe a little bit cluttered there in the book when you look at it. And there is one little piece to it that I'm not crazy about how they have it drawn. So let me just explain a little bit of the setup here and see if I can help you get kind of pushed through how to start this. The problem says the Wonder Wheel Ferris wheel at Coney Island has a radius of about 68 feet and is 15 feet off the ground. So these are the two really important pieces of information that we want to make sure that we're including on the picture. Okay, so on the picture, and there's all kinds of radii you can draw on a circle. Like if you have a circle, here's a radius, there's a radius, there's a radius. You can draw all kinds of radii on a circle. And so any radius that you could draw in this circle, it is going to be a distance of 68 feet. Okay, so and then they tell you that the wheel itself is 15 feet off the ground. So here's what I know. I know that this gap right here from the bottom of the wheel down to the ground, we can definitely label that is 15 feet, okay? Now, the question is, and we'll go back and address the radius here in just a second. It goes on to say, after a person gets on the bottom, you'd always enter right here on the bottom, come up some type of ladder and get on the bottom here, okay? It says it rotates 202.5 degrees counterclockwise, okay? So if we're going counterclockwise, it means we're going in this direction, okay? And you're going to go that direction 202.5 degrees. Now, what I don't like about the picture is I don't like that they put this number sitting all the way over here. I think that they should have taken this number here and they should have moved it right over here next to point A, because technically if you are getting on down here at the bottom and then you rotate 202.5 degrees, that's going to land you right here in this spot A. That would be the carriage that you would be sitting in. Okay, so it was a little misleading when they had the 202.5 degrees sitting over here. Okay, now here's the question. How high above the ground is this car when it has stopped? So ultimately, we're wanting this vertical distance straight down from A down to the ground here. Okay, so let's see if we can piece together what we're given, kind of add this onto the picture to help you see how we could answer this question. Okay, remember at the beginning, they said the radius of the wheel is 68 feet. Okay, so that means that this space right here, that's an example of a radius. I could label that as being 68 feet, okay? So if my goal is to get this distance right here that I have labeled off to the side, this segment that's in black, right now I know from here all the way down to the ground would be this 68 feet plus the 15 feet that the Ferris wheel is above the ground. So I'm going to add 68 and 15 together. That's going to give me 83 feet for that section there. Okay, that leaves us with needing to figure out this other distance here so that we could add that to the 83. So let's look back at the picture here. Okay, if you look back at the picture, that segment that I highlighted in yellow, that's the same thing as this piece right here. Okay, and if you can kind of focus in on this right triangle here, let's see if we know any of the sides of this triangle. Okay, now remember earlier it says the radius of the wheel is 68 feet. Now if you look at that triangle, is there any aspect of that triangle that you would say, oh, well, that's actually the radius of the circle? Okay, hopefully as you look at that, you can see that the hypotenuse is also the radius of the circle. So the hypotenuse would be 68 feet. Okay, now the goal though is we want to know what this vertical leg is. So I'm going to label that as X. Okay, I'm always going to put that theta symbol in my triangle closest to the origin, and then I'm thinking through which trig function should I use to help me find that vertical leg. Okay, hopefully from here you can pick the correct trig function, set it up, solve for side X, which would be this missing piece right here. And once you have side X, you're going to add the 83 feet to that. And that's going to answer the question, how high above the ground is this car when it's stopped right here at point A? Okay. Hopefully that helps and provides a little bit of clarity for you.